If someone offered to sell you a nuclear power plant tomorrow, your first thought would probably be simple. How much does it cost? A few $1 billion? 10 billion? Maybe more? That sounds like the obvious question. It's also the wrong one. Because if you somehow had unlimited money, buying the plant would still be one of the easiest parts of the entire process. The real challenge begins after your signature is on the contract. Can you legally operate it? Can you hire the thousands of people required to keep it running safely? Can you convince regulators, insurers, financial markets, nearby communities, and the electric grid that you deserve to own? One of the most tightly controlled industrial facilities on Earth, a nuclear power plant looks like a giant machine. In reality, it's an ecosystem of engineering, law, finance, politics, and public trust. And understanding that changes what ownership actually means. Because you're not really buying a reactor. You're buying responsibility that can last for generations. That becomes clear almost immediately. Most people assume buying a power plant works like buying any other industrial business. The previous owner agrees to sell. Lawyers prepare contracts. Money changes hands. The new owner takes over. Nuclear power simply doesn't work that way. In countries like the United States, changing ownership requires extensive regulatory review by the U.S. Nuclear Regulatory Commission. The regulator doesn't just ask whether you can afford the purchase. It asks whether you're capable of operating the plant safely. That means examining technical expertise, financial stability, emergency planning, security programs, maintenance procedures, cybersecurity, even the qualifications of the people who will supervise daily operations. Because unlike most businesses, failure isn't measured only in lost profits. It's measured in public safety. That creates an unusual contradiction. The reactor itself is designed with multiple layers of physical protection. But before you're trusted with those protections, regulators first have to believe that your organization deserves them. In other words, the most important safety system isn't made of steel or concrete. It's institutional competence. And that's only the beginning. Let's assume every regulator approves your purchase. Congratulations. You now own a nuclear plant. So where does the money come from? The obvious answer is electricity. But that explanation misses how the business actually works. Nuclear plants don't become valuable simply because they generate enormous amounts of electricity. Many technologies can do that. Their real advantage is consistency. A typical large reactor can operate for roughly 18 to 24 months between refueling outages and often achieves very high capacity factors, meaning it produces close to its maximum possible output over the course of a year. That predictability matters enormously. Electric grids must balance supply and demand every second. A hospital doesn't care whether the wind stopped blowing. A semiconductor factory doesn't want power interruptions because clouds rolled in. Entire economies depend on electricity arriving exactly when it's needed. Nuclear plants are designed to provide that dependable foundation. In many markets, they're part of what's often called baseload generation, the steady supply that supports the grid while other sources fluctuate. Suddenly, the business looks different. You're not just selling electricity, you're selling certainty. And certainty is expensive to build, but surprisingly cheap to fuel. People often imagine uranium as the main expense. It's actually a relatively small portion of a nuclear plant's lifetime operating costs, compared with staffing, maintenance, regulatory compliance, security, insurance, periodic upgrades, and eventually decommissioning. That surprises many people. The fuel isn't the dominant financial challenge. Everything surrounding the fuel is. Which brings us to perhaps the biggest misconception of all. Most mega projects become cheaper once construction ends. A shopping mall opens. Customers arrive. Revenue begins. A nuclear plant never really reaches that stage. Instead, it enters decades of continuous inspection, equipment replacement, testing, operator training, emergency drills, cybersecurity improvements, and regulatory oversight. Every valve matters, or procedure matters. Every inspection matters, because a tiny failure today might become tomorrow's major incident. This is where the economics become counterintuitive. Many industrial businesses maximize profits by reducing costs wherever possible. Nuclear operators certainly pursue efficiency, but cutting the wrong cost can become vastly more expensive later. Skipping maintenance isn't merely risky. It can trigger shutdowns. A reactor that's temporarily offline isn't owning revenue. Yet many costs continue. Employees still need to be paid. Security still has to be maintained. Loans still require repayment. And regulators may require additional inspections before restarting. Now the chain reaction begins. One equipment problem causes an inspection. The inspection uncovers additional issues. Repairs take longer than expected. The outage extends. Electricity sales disappear. Financial pressure increases. Investors become nervous. The operator delays other investments. Regulators demand more evidence. Public attention grows. One technical issue slowly becomes an organizational problem. And organizational problems are often the hardest to solve. History has shown that serious nuclear accidents are rarely explained by a single broken component. Investigations frequently identify combinations of equipment issues, human decisions, organizational culture, communication failures, and unexpected circumstances interacting over time. That's an important lesson. Complex systems rarely fail in simple ways. There's another hidden cost almost nobody thinks about until decades later. Eventually, every reactor reaches the end of its operating life, but switching it off doesn't end ownership. Now comes decommissioning. The plant must be carefully dismantled. Radioactive components must be handled safely. Large volumes of material have to be sorted, transported, or stored according to strict regulations. The site may require years or even decades before all work is complete. Owners typically accumulate dedicated decommissioning funds during the plant's operating life precisely because those future obligations are expected long before the reactor closes. In other words, the day you buy a nuclear plant, you're also accepting responsibility for taking it apart someday. The final chapter is planned before the middle chapter even begins. That tells you something remarkable about this industry. Time operates differently here. A normal business plans for the next quarter. Nuclear operators routinely make decisions whose consequences extend 50 or 60 years into the future, sometimes longer. A real example shows how dramatically circumstances can change. Consider 3 Mile Island Unit 1 in Pennsylvania. Most people recognize the name because of the 1979 accident at Unit 2. That event transformed public perception of nuclear energy worldwide. But Unit 1 was a separate reactor on the same site and continued operating for decades before closing in 2019, largely because economic conditions had become unfavorable in competitive electricity markets. At first glance, that seems like the end of the story. An aging plant closes. Except it wasn't. Years later, growing electricity demand, particularly from large data centers and expanding digital infrastructure, helped revive interest in dependable, carbon-free generation. Plans were announced to pursue restarting Unit 1, subject to extensive regulatory approvals, technical work, and commercial agreements. Notice what changed. The reactor hadn't suddenly become more powerful. Physics hadn't changed. Instead, the surrounding system changed. Electricity demand evolved. Climate priorities shifted. Reliable generation became more valuable. The same physical asset began looking completely different because the world around it had changed. That's a powerful reminder. Infrastructure doesn't exist in isolation. Its value depends on economics, technology, regulation, and society moving together. Which brings us to perhaps the strangest discovery of all. The reactor isn't actually your most valuable asset. The most valuable assets are far less visible. A trained workforce that knows how to operate safely. An organization trusted by regulators. Operating procedures refined over decades. Relationships with suppliers. Emergency planning with local authorities. Institutional knowledge that cannot simply be purchased overnight. You can build concrete. You can manufacture steel. You cannot instantly manufacture trust. And trust in nuclear power behaves almost like infrastructure itself. It takes years to construct, minutes to damage, years to rebuild. So what if everything goes perfectly? In the best case scenario, you own an asset capable of producing enormous quantities of low-carbon electricity with remarkable reliability for decades. If managed well, license renewals and major maintenance investments can extend productive operating lives significantly, allowing the plant to continue supplying electricity long after many other facilities have been replaced. The realistic successful outcome is less glamorous. You spend decades solving thousands of small problems before they become large ones. Most days are intentionally uneventful. That's success. The realistic negative outcome isn't necessarily a disaster. It may simply be economics. Electricity prices fall. Maintenance costs rise. Major upgrades become difficult to justify. A technically sound reactor becomes financially unattractive. And the failure scenario, the one everyone fears, is why every other layer exists in the first place. The engineering, the regulations, the inspections, the training, the paperwork, the security, the culture. All of them exist because the consequences of getting things wrong can extend far beyond the plant's fence line. So if someone really asked whether you wanted to own a nuclear power plant, the answer wouldn't depend on how much money you had. It would depend on whether you were prepared to inherit decades of responsibility, scrutiny, planning, and continuous discipline. At the beginning, owning a nuclear plant sounded like buying an incredibly expensive machine. By the end, it looks much more like accepting a long-term promise. A promise that every decision, every inspection, every employee, and every future owner will protect something larger than the business itself. Because beneath the concrete, beneath the reactor vessel, and even beneath the electricity it produces, a nuclear power plant is not fundamentally a machine. It's a system built on trust that just happens to generate power.